So, today's video is on how to calculate what time an electronic device will be working on a particular battery. So, here as an example, we have considered one 750 milliampere hour battery. If you still don't know what is meant by this milliampere hour, then I would request you to see my previous videos on batteries. Okay, so there is a small equation to find out that is the time it will be lasting will be equal to current rating of the battery divided by current requirement of the device. So current rating of the battery, from where you will be getting this? Most probably it will be written on the battery itself. Otherwise, you can directly search in Google on current rating of that particular battery. Battery's model number will be printed on the battery itself. Just Google on current rating of the battery. That's it. So you will be getting a value somewhat similar like this. Now the second thing, what is this current requirement of the device? Current requirement of the device also you will be able to get directly from the internet. For example, here I have just searched current rating LED. That means I need to know the current rating of an LED. So in the first page itself, I can see over here, most common LEDs require a forward operating voltage of between approximately 1.2 to 3.6 volts with a forward current rating of 10 to 30 milliamperes. So 10 to 30 milliamperes means we will just take the average of that. Okay, so average of 10 to 30 milliamperes is 15 milliamperes. We'll be just be considering 15 milliamperes for the calculation. We can see some examples, real-time examples one by one. So first of all, I am going to calculate the time that one single LED will be lasting on two 1.5 volt batteries that is having 750 milliamperes each capacity. So why two batteries? Because one battery mostly won't be able to drive the LED. So in the previous page you have already seen most common LEDs require a forward operating voltage between approximately 1.2 to 3.6 volts. We will again just take the average of that. So it will come nearly say 2.5 volt. So one battery it can provide only 1.5 volts. Correct. So that's why we consider two batteries. So two batteries means connected in series will be giving you 3 volts. So in this case, we can consider the time that one single LED will be lasting on two batteries of 750 milliampere hour each. Okay, so how to calculate this? First of all, current rating of the battery. In this case, what is that? 750 milliampere hours divided by current requirement of the LED. In this case, what is the current requirement? 15 milliamperes. From where we have got that? In the previous page, I already told how to get this value directly from Google. So finally, we have calculated if we are having two batteries of 750 milliampere hour each, then a single LED will be lasting for 50 long straight hours. Now coming to the second real-time example, that is a mini motor. Have you seen such motors? As a kid, if you have tried to repair any of your toy cars, of course you might have seen such a mini motor in all your toy cars. Normally, two of such mini motors will be present inside toy cars. One such motor that will be used for driving the toy car forward and backward, and the second mini motor it will be used for turning the car left or right. What if you are having such a mini motor with you and you need to calculate how much time it will be running on battery? Okay, again this mini motor is also having a voltage rating of 3 volts. If you are having any doubts, just Google mini motor space voltage rating. That's it. You will be getting 3 volts. So that means how many batteries you need? You need at least 2 batteries in order to power up the mini motor. Okay. In such a case, again, time it will be lasting can be calculated like this. Time it will last is equal to current rating of the battery. Again, we have considered a battery of 750 milliampere hour alone for taking this example. So 750 comes over here divided by current requirement of this device. Current requirement, directly you can search in Google current rating of mini motor. You will be getting it as 300 milliampere. So 750 milliampere hour divided by 300 milliampere. So two such batteries will be able to power up a mini motor for 2.5 long straight hours. So in a toy car, there are loads of electronic components. What all components are there? Motors will be there, LEDs will be there. In some of the toy cars, buzzer will be there in order to make some sound. And apart from that, some circuits also will be present. So for all these things together, we need to calculate the current requirement first. So we will see here how many motors are there. In the front, one motor will be there in order to make the toy car turn left as well as right. And the back side, another motor will be there in order to make it run forward as well as backward. Okay, so two motors are there, and two motors means the total current requirement will be doubled there. That is 600 milliamperes will be coming. Now what about the other things? Apart from the motors, LEDs will be there, right? Used as headlight and all. So LEDs will be there. Some circuit will be there. Of course, some in very few toy cars, buzzer also will be there in order to make some sound. So together all these things we can take it as say 150 milliampere or something. Okay, so total of 600 plus 150, that means 750 milliamperes will be taken by a single toy car. Now we need to calculate what time it will be lasting. As we discussed before, same equation will be considering here total current rating of the battery divided by total current requirement. Okay, so as a first case, we'll just consider a toy car with two batteries. As I told before also, most of these electronic devices require at least two batteries to function, because most of them are rated for 3 volts. LED, it is rated for 3 volts. Circuit, it may be also be rated for 3 volts. What about the motors? I have already told this before, it is also rated for 3 volts. So as a pair only we will be considering. So two batteries. So for both the batteries, the current rating will be 750 only. Okay, as a pair only we are going to take 750 milliampere hours divided by 750 milliampere. From where we got this 750 milliampere? Just after this calculation, the value was 750 milliamperes. So both these things are going to get cancelled. Finally, only this hour value will be remaining. So that means 1 hour. So you can use a toy car for straight 1 hour or so for two batteries of 750 milliampere hours. The same example for a toy car which has provision to insert 4 batteries. In such a toy car, again, we'll be grouping 2 batteries each as a pair, and other 2 will be considering as another pair. So this toy car, it will be having 2 into 2 batteries of 750 milliampere hour each, divided by what? Divided by total current requirement. Again, here also it is 750 milliamperes. We will be putting that over here. 750 milliampere here, and this 750 milliampere here will be getting cancelled. And finally remaining is 2 hours. So final value is 2 hours. Okay. Anyway, these are theoretical values alone, but in a practical case, due to braking, transmission losses, temperature losses, etc., some more power loss will be there. Due to that, for 2 battery toy car, it may last up to say 45 minutes, and 4 battery car, it may last up to 1 hour 30 minutes effectively. Thank you.